Hi everybody, and welcome to the Future of Transport session, where we're going to be looking at how space and geospatial data can play a pivotal role in the future of transportation. My name is Daniel from AstroAgency in Space Scotland, and I'm joined today by my wonderful colleagues.
Hi everyone, I'm Christina Tamana. I am a Space Business Development Executive at the University of Edinburgh and a Space Scotland member.
And I'm Ashley Stewart. I'm from Optimat and I'm currently managing the Location Data Scotland, which is Scotland's geospatial community. So thank you all for joining us. We've got a fantastic lineup of speakers today, and we've got our first session is with our keynote, who is Hina Khan from Spire Global. So I'll hand over to you, Hina, and Hina's going to talk about how space links to transport.
Thank you very much. I'm just going to share my screen. I hope you can all see that. So thank you very much for inviting me to be part of this session organised through the KTN on space and geospatial data through the COP26 forum. It's a fantastic opportunity, and I'd just like to take a few minutes today to kind of introduce this session, which I think is a fantastic line of people, to talk about what the future of transport looks like when we think about space data. So when we think about transport, we think planes, trains, automobiles, and also ships. And really what's interesting to understand is that even today, space data is used throughout the transport network. So, we have a number of systems which can be used, which allow us to really make important decisions and tools that can be leveraged to inform and provide better logistical navigation systems, but also mobility and the movement of goods and services. So from looking at shipping data using AIS tracking from low Earth orbiting satellites to give us a reliable information on transit time of goods and input into ports. Our rail networks and where we have a vast amount of infrastructure on the ground and over land through bridges, and really the distortions in the movement of the ground can be monitored from satellite and space data as well. As we move into the air and we look at aircraft data, obviously there have been huge challenges of late in identifying, and making sure that safety is obviously the primary, the principal aim of making sure that air travel is safe for everyone, and tracking and the continuous monitoring of aircraft is something which has been in force since 2018 and can really only be done at that time scale from the use of satellites. And then obviously on the kind of ground networks, our buses and our cars, looking at smart technology buses in terms of connectivity to be able to provide a really robust system for continuous tracking, but also in our motor industry to make sure that our cars are the safest they can possibly be by making sure that we get safety and software updates to enhance that capability. So really you can see that throughout all of our transport network, we already have a fair amount of space and satellite data, which is used to make our lives better, but also to try and ensure that the systems that we're using are trying to meet our environmental targets as well, from monitoring emissions and air quality, which I'll talk a little bit about in a few minutes. So what needs to be done if we're already doing all of this and we have a good network of links into the space industry through transport? What is it that we need to be able to do better? Well, actually, one of the biggest challenges, and I'm sure many of you obviously now that we're remote, but when we all get back in our vehicles and public transport network, connectivity is such a massive big deal. We do need to be much better connected. And okay, in the cities and larger towns, that's not so much of a problem, but actually when you go out into rural communities or the less developed countries, then actually connectivity is a much bigger challenge. And so if we were looking to how we can make our transportation networks more reliable and robust, then connectivity absolutely has to be at the forefront of that, and ensuring that connectivity is uniform and reliable across the entire system is really, really important. Also making sure that our systems are smarter, so our networks are smarter. Well, what does that mean? That means that in areas where we have data, we use that and we use it in a good way, but actually we can also supplement that through machine learning tools and AI technology. And what that means is it gives us an added value and a kind of predictive element to how we can make better decisions and use our systems in a more informed manner that then allows us to make better decisions and make these environments a much better way of using. And then infrastructure as well, charging points, and then the use of coordinated geospatial data to making it. And ultimately what we're trying to do is make our transportation greener and cleaner. That really has to be the future for where we want to go. And connectivity and data are all around us. You know, we need to have performance of the high performance computing, which allows us to make these decisions. And that data has to be rooted in a way which is manageable, but also actionable for us to deliver economic value from it. You know, when we think about electric vehicles, then we need to be able to have the charge points in places that people feel confident that they can get to those points, charge their vehicles, and have a range that they would be able to get to their destination. So we need to be more efficient in the way that we manage our systems and networks. Other systems such as drone delivery, which is already being used, you know, but we need to have a very precise understanding of our mapping and our location in order to be able to really optimize on these areas. You know, at the moment we have these systems in place, but there are still gaps in our knowledge and gaps within that environment which don't make these parcel delivery and autonomous vehicles as robust as systems as we need it to be. So really we need to have that infrastructure for the network that we need to develop in order to be the transportation for the future. And really some of these things are already happening. You know, we are already combining our data sets, you know, in the shipping and the maritime industry, we are making actionable insights by using combined AIS data to be able to make decisions and provide situational awareness tools to be able to identify where there may be some untoward activity going on. And that's important for insurers and for other players where they have legislative compliance issues that they need to be aware of. But also we have to be able to combine our data sets. So, you know, this was the picture at the bottom is a little video of the Soyuz tanker, which got stuck for, you know, a fair number of days, you know, a week or so, and it caused a huge issue within our logistical supply chain. And really the combination of the weather data with what we know of transportation meant that we could have perhaps been a little bit more informed in how we had these, how we managed the challenges that are that we need to be addressed in these areas. So really it's how we combine our data to make our transportation networks more useful in what we're trying to deliver. When we think about aviation, obviously aircraft have had a huge challenge over the last 2 years or so, but really modern aircraft are collecting a vast amount of data. And this data is there for improve the performance of the aircraft, but also in terms of safety and experience. And really that data collection is really used to help the decision makers, but also the aircraft carriers and the suppliers to be able to ensure that their aircraft are more greener and economic in their fuel. And again, the combination of data sets provide you with reliable route planning, but also logistical transportation. You know, and during the global pandemic, obviously there have been huge challenges within this industry. And an example of this is the reduction of air travel, obviously over this timeline. But specifically, you know, the kind of workhorse of what was deemed the pinnacle of air travel, the A380, you know, one of the largest aircraft in the skies. Actually, that's now being rethought and being considered. Perhaps there needs to be another way to consider how aircraft and air travel is taking place. So really what's happening is that we're seeing the fleets of A380s being reduced by considerable amounts and actually being replaced by greener, more fuel efficient aircraft because the demand is not there in the same way as it was. And so the industry is changing. And really the satellite data has been able to help understand the changes in that industry to be able to move forward. I wanted to take just a few minutes just to talk about, how we use the variety of data that we get from space. It's not just about, the tracking and logistical aspects. We use it in our critical infrastructure. We use it to look at the movement of land and bridges and structures to be able to ensure that these things are safe, and also we have early detection systems. We also look at in terms of, communication networks and for safety, and also the digitization of our ports and other environments. And really, it's a combination of all of the transport systems that we have that allow us to think more holistically about how can space really be enabled to make these environments safer, but also the best in the way that they can possibly be. And so just to conclude on that, I only have a few seconds left, but really, we are working in a really cooperative way with the transport networks and how space data can be used. But really what we need to think about is we need to develop the infrastructure and the critical aspects of these networks that allow us to really benefit for a greener, more connected network. And that is done through a combination of satellite, ground-based, and also airborne tools. And geospatial data is really a key aspect of that. And you'll hear from a number of speakers later on this afternoon on the different aspects that these are delivering into and the different areas within which space can add value. But ultimately, connectivity has to be one of the most important aspects. How do we improve connectivity to allow us to be and provide more reliable services? And then to make sure that that information is translated across the different stakeholders in the non-space environment to really be able to see the full potential of what geospatial and space data can provide in this environment. So I hope that gives you a little bit of flavour. Thank you very much. And I'm happy to take some questions. Thanks, Christina.
Hello, Hina. Can you hear us okay?
Yes.
Wonderful. Thank you so much for that presentation. That was very interesting, and it's good to see that overall picture, which I think you presented extremely well. So we have had some questions come through while you were presenting. The first question was, how can data, especially geospatial data, be standardized across the many different modes of transport and mobility, do you think?
So this is a really big challenge, and I think it's one of the things that makes people from out with the space sector quite hesitant to be to use space data, because they feel that it's only in the domain of the very few experts that understand that data that can really deliver, they can really apply that. So I think there is work that needs to be done from our community to work very closely with those entities to understand, well, we have to be more uniform. We have to be able to provide data either through an API network or through a data stream, through some sort of data lake possibly, that allows people to access that information quite readily. It is a really interesting challenge, and one that's not has not yet been solved, because I think the data formatting is a big issue. But working in partnership with the transport networks, Transport Scotland and environmental agencies, to understand, well, what are the needs that you have, and how can we provide that in a way which is ingestible into your data sets. It's no good for the space community to come out and say, right, well, this is the way we have it, and that's what you have to work with. We want to work in partnership with them, and really it's an enabler. We want to be an enabler. We don't want to be a blocker. So it's in our interest to make sure that we work in that partnership mode to deliver on that.
No, that's wonderful. Thank you. Hopefully that answers the question. Ashley?
Yeah, and the second question is, how can the EV industry provide plentiful charging points, both for people without driveways and those in remote rural locations, effective maintenance of faulty charge points, and security against crime when the public's having to use communal charging points?
Yeah, this is a problem close to my heart, and I think there's a lot of us who really wish they could move to electric vehicles and want to be in that zone of being, proactive in how we deliver that. But it is a real problem. How do we deliver this? Again, I think there's a lot of work. There has been work that's been done which looks at the kind of movement of people and how we want to manage our infrastructure. I mean, I think we would love to get to a position where we have charge points across our entire country, you know, rural and urban. But really the practicality of that would be immense, and the cost of that would be significant. So I think we need to look at slightly more creative ways on how we can provide that. Now, obviously, one area is, you know, by having on, you know, maybe on a, you know, on a street or something where we have a number of charge points which can be accessed, but also working with the car manufacturers. You know, there are some areas that people say that, you know, that it's been suggested that actually you don't need anything more than a 3-pin plug to be able to charge your vehicle. So is there a way that we can use the utilities networks to be able to provide that infrastructure as a more uniform application? In terms of security, again, yes, this is something I know in the city of Glasgow, you have charge points, but you know, there's nothing to stop someone pulling up beside you, unplugging your vehicle and plugging in somebody else's. So I think this is absolutely something that needs to be thought out, and hasn't, you know, we're still in the beginnings of this industry of electric vehicles, but it's definitely a challenge that needs to be considered. And you know, space will have a role to play, and how we do that, I think, is what we need to figure out.
Another question, Hina, is do you know of anywhere that's done this particularly well? Anywhere where the kind of automation part and the space data part have come together to build an infrastructure that works really well globally?
So I think there are some nice cases. I think across different domains. I think, you know, I think maritime has been an industry which has been using space data for quite a long time, you know, the tracking of the ships. And so that's being combined into kind of more kind of smart ports, you know, smart port authorities and using smarter networks. And that's really been, you know, it's something that's been happening for a long time. So, you know, that's a slightly more mature environment. That's not to say that all ports are using space and satellite data, but there is a little bit more of an understanding of how you can use that. And the logistical network in that environment is really key, because obviously they have huge challenges in ensuring that their cargo and the networks are maintained reliably and securely. And so satellite data has been used quite effectively in that. I think what's coming to play now is not just using a single resource to be able to deliver, you know, within the maritime industry or elsewhere, but actually it's combining different sets of data, be it from ground networks or also satellite data, but it's combining the different aspects that allow you to make more intelligent decisions, you know, make more intelligent choices. So, you know, if you have, you know, kind of logistical, you know, satellite data, which is showing you that the cargo ships are coming into a particular port, but actually that port is blocked because of other things, because of the ground data, then you can navigate round to another area in that environment. So it's a combination of data, but I think, you know, transportation as a whole is using space data, but it's still quite needs to be more connected in the way that we think about that.
Brilliant. I think that was it for the questions. I'm just gonna
it.
That is wonderful. Thank you so much, Hina, for your time and for the presentation. That was a fantastic keynote speech, and thank you for kicking us off for the session today.
Thank you very much.
Excellent. We will hand over to Hayden Sutherland for an interactive session with our audience. Hayden, over to you.
That's great. I'm just going to share my screen. So thank you very much. And with the, this is going to be interesting with the lag that we have between me presenting and the questions. I'm trying to keep it interactive as possible, but I'm going to skirt through a few slides first of all. Firstly, hello delegates, and thanks KTN for the opportunity to speak very quickly at this event. It's great to talk to you all. My name is Hayden Sutherland. I'm the founder and chair of the Open Transport Initiative. We're an organisation that was set up a few years ago to develop and promote the use of open standards for sharing transport and mobility customer account data, primarily done via APIs. In making sure that that data is interoperable across numerous different modes of transport and mobility. You notice I've used the word transport and mobility rather than just transport. I think it's clear that we involve the word mobility as well as transport when we have conversations about transport, although the two terms are used really interchangeably most frequently. But there is a subtle difference between them. Usually transportation is used to mean the act of moving goods, as freight and people, but mobility tends to be associated with the ability to move freely or be moved. It's a bit of a different way, and it actually then plugs into the mobility as a service concept, which really is the shift away from ownership of vehicles and the shift of tickets that sold pre-sold more to an on-demand suite of transport and mobility services. Or in short, transport is something you do and mobility is something you have at your disposal. And there's numerous different definitions, but those are most used. What I'm going to take you through this afternoon is a map of the different transport and mobility modes. This is trying to be an interactive session, so I'm relying on my peers in the rooms to flag up many questions and any suggestions. So what I'm going to present to you is an artifact that was previously designed by the Open Transport Initiative to try and communicate just how complex all the different terms and the different the terminology and the definitions of transport mobility are. Because this is a geospatial and space-based conversation, we're updating this. I want to present to you how this is an updated version of that diagram. But it's also published under Creative Commons, so it's free to be used by everybody as they are, as everybody as they want. So there you go. Right. The easiest way is to throw some circles with some words up there with some modes and actually show you this. What I'll do is I'll do a first couple of slides and then I'll go to if there's any questions. I'll do a few slides first of all, and then we'll go to that if that's possible. The reason I put these these circles up there to represent the different modes of transport and mobility. You may say, okay, then, well, what are all these different modes? You might recognize them from your bus and your subway, your taxi. And your shared cycles, and I've included cycles here, but that can include cycles, and then we'll talk about e-cycles, battery or electric powered vehicles, including the other ones, including such as scooters and segways and those sorts of mode of transport as well. But more blatantly, you can actually then draw some sort of Venn diagrams around these different modes of mobility, and you can start to explain, well, these are vehicular based modes, and these are also then transport and passenger transport based modes. The term transit is also, as we know, used and tends to mean public transport, and those usually mean I should actually explain, what does DRT mean? That's a very good question. First of all, demand responsive transport. What that tends to mean is the more on-demand form of sort of cars or demand services. So you might have hopper buses, on-demand services for local hospitals or local older people or accessible transport. So that's DRT. And I'll try to make sure I explain all the TLAs or the 3S acronyms. There's a couple of questions I'm going to go to straight away. I think, is there any questions? No, that's good. I haven't had any questions so far. So moving on, it's worth then saying, right, well, if we move on now to drawing this diagram out of it, we actually talk about, well, mobility really starts to play. If you talk about active travel on foot, private cycling, and the move to a shared cycling, that really is what we're really trying to push, and really trying to encourage an active lifestyle. But then that overlaps with the definitions of what is known as micromobility, which tends to mean the shared sort of two-wheeled devices and modes of transport that we know that are cropping up more and more across more and more cities and geographic regions. Tends to be these shared services aren't privately owned, or some of them can be, but many of them are on a pay-per-use. If you have to go around Glasgow or London or any major cosmopolitan city to see pay-per-use cycles or scooters being increasingly in use and being trialled around the globe. Obviously, those ones here are the self-driven modes of transport, and these, as you notice, and they're all on land. So they're all there all the different modes that we would associate with being on land and traveling about as we go and do our daily business. Now, it's also worth mentioning I have tried to explain that from the bottom left of this diagram through to the top right tends to be, because this is COP26, that the CO2 usage of these vehicles tends to mean that the bottom left tends to be greener and leaner CO2 emissions than the top right. It's figurative because, as we all know, there's lots and lots of variation in that area. And then it was mentioned before, actually, Hina mentioned about marine, and that it's the significant amounts of transport mobility that's done across that sector. And they then come into the water bus. Ferry is a marine here, and then shipping for more freight. These fit in, and as we go, we find out the air, as we come into the air, we build aeroplane and we build air freight into that. Now, what I have then encouraged to do is then move on and then say, right, not just personal mobility, sometimes there's the opportunity to include land drones, and then I have used two acronyms there, sort of your underwater or your unmanned underwater or vehicle, a boat and a submarine unmanned, and then your air drone, your unmanned aerial vehicle as well. Finally, we have added in for this new presentation and this new version of this diagram, the space and geospatial modes of transport, space passenger transport, your Blue Origins of this world, your space freight. And as we know, the likes of Elon Musk are going to become one of the largest space freight organizations, potentially, and others like that. And then you've got uncrewed craft that there's increasingly been sent up, as well as potential for space berthing. Now, I have included the berthing and parking mooring down here because it's not just how we consume these vehicles, but also when they're not being used, we have to find a place for them. Now, I have, hopefully I've covered quite a bit there. And so I was going to see, hand it back to my peers and say, have we got any questions on here? I think here's my contact details. If you want to get hold of us at the Open Transport Initiative, here's our URL and here's my contact details. So I'm going to say, is there any questions from the floor?
Hi Hayden, thank you for sharing the mapping with us and for beginning to kind of extend that out to include space and geospatial. There's one question come through which is quite similar to one that was in the previous panel relating to the need for EV charging. So the question is, do you think that local authorities should use their electric network better to enable EV charging, for example, lampposts? Orkney apparently are doing this very well.
If my honest opinion is that everywhere needs to consider the infrastructure for electric vehicles, but we should consider that electric vehicles aren't just a panacea we want. Electric vehicles still cause congestion, and we're probably going to get into new different congestions with electric vehicles. So yes, I would say that there should be a commitment for every area to consider how we use electric vehicles and how best they are surfaced, especially for people without driveways. So they should be made more of a public utility. But we also should need to understand how we're using them. And also, if we are really going to talk about proper decarbonisation, we should probably then look at how we push people into the more larger usage, bigger vessels to transport them in. Rail and bus are the most easiest way. A big metal tube is the easiest way to take lots of people from A to B. So in a mobility as a service infrastructure, you need to record things like EV data and the EV charging definitely, but you need to join it up with other modes of transport and mobility as well.
Great, thank you.
Just another quick question, Hayden. So what is the biggest challenge to consistent and open standards in transport, particularly with MAAS in mind?
The honest answer is we spend a lot of time trying to get data interoperability between different mass providers and mass services and the regular transport and public transport network. The honest answer is that we are really pushing that when introducing or when setting up a new mobility as a service system, really needs to be a fundamental requirement baked into every new mass platform, that when put in, it is interoperable with other MAS platforms and other transport data. If you can think of the portability of your MAS account, your usage, your entitlement, where you can go, when you can travel, how often you travel, that data should be portable into electric vehicle data. It should all be interoperable. There's significant resistance to doing that right now, because lots and lots of organizations setting up MAS platforms think of themselves as the data is, it's theirs to be used. When in reality, it's the user's data, it's the personal data that is theirs to be used as well. So the data needs to be portable. The data needs to be, and those requirements such as interoperable data and data sharing need to be baked in from the beginning of every contract, every new setup, and every new MAS platform or a MAS scheme.
Great. Do we have time for any more?
I think we've got time for one more question. So again, it's tying into MAS. So how do you think that MAS could alter the popularity or dominance of the modes that you've presented on the map?
Well, that's a great question. My fundamental belief is that the public sector of the transit modes are the backbone of any MAS that you set up. And that to say that it therefore needs to be a sort of a coordination between the public sector and transit, such as the ones in the middle of the train, the tram, the bus, those modes. They need to be the backbone, but they need to work with every other platform as well. So I think we have the potential, by using data correctly, by using data joined up, don't forget, no data, no decarbonisation. You really need to join that data up and then start to change users' behaviour. Because it's only by having a collective view of how we all burn carbon, how we all use it, and by having a joined up view of data, a complete dashboard of every single mode and how it's all using CO2, that we can then hope to change people to cleaner, greener ways of transport. And if we're going to do what we're promising at COP26, don't forget, transport mobility is the second largest creator of CO2 emissions globally. We have a huge responsibility in our sector to decarbonize. So by using joined up data, we can then change people's behaviors at an individual level so that we can meet our promises for decarbonisation.
Great, thank you very much, Aidan. There's some more questions coming through, but we're running out of time. So what we'll do is we can take the questions offline, and likewise the map that Hayden shared with us today, that will be available on the portal after the session. So if there's other ideas, feel free to stay engaged with us, because we can continue to build this out almost as an output and an outcome of today's session. But fantastic, thank you very much, Aidan. So I'll now hand over to Deborah Payton from Glasgow City Council. So this is going to be your first panel session, and Deborah's going to chair that for us, and she'll give an overview of the speakers and the panel session itself. So over to you, Deborah.
Thank you very much, everyone, and thanks for having me along today. So my name's Deborah Payton and I work at Glasgow City Council. I'm really interested in the use of geospatial and space data in transport. At Glasgow, we've been making a lot of use of innovative data around location services recently, working with the academic sector to better understand travel demand and how that's been changing over the last 3 years in particular, after lockdowns and during lockdowns. And plus, we also have a collaborative system whereby late running buses in the city use GPS and get signal priority as part of our urban traffic control system. So there's already lots of examples, I think, how space and geospatial data is being used. But today in this session, we're going to talk about a few more examples from the panel of experts that we have with us. So really excited about that, and I'm just going to let each one of them introduce themselves in turn now, and I'll turn first to Geraint.
Well, good afternoon. Hi, everybody, and thanks to KTN for the opportunity to take part today. So I'm Geraint Cooksley, the Head of Geoinformation at Telespazio UK, and Telespazio UK is a Leonardo and Thales company, and our company works across a broad range of satellite services. Thank you.
Thank you, Geraint. And moving on to Simon.
Thanks, Deborah. So my name is Simon Mudd, and I'm Professor of Earth Surface Processes at the University of Edinburgh. And I work on natural hazards, landslides, debris flows, flooding, and other things that use remote sense data.
Fantastic. And I think we'll be hearing more about all of those examples in just a second. Introduce you to Catherine.
Hi there, my name's Catherine Elsom and I'm the Head of Marketing for Intelligence UK at Airbus Defence and Space. I've got a background in Earth observation and geospatial data applications, and today I'll be talking about how this sort of technology can support monitoring of maritime activities and shipping emissions.
Fantastic. And finally, Katie.
Hi, my name is Katie Chesworth. I'm a Principal Transport Planner and the Head of our Sustainability in Transportation across the UK and Europe at Mott MacDonald. We're a carbon neutral engineering, development and management consultancy.
Brilliant. So without further ado, let's get into some examples of the work that all you guys have been doing and how you're applying space and geospatial data to the field of transport. So if we maybe make a start with Geraint and Simon, because I know you've been collaborating with each other on a number of projects. Your work has been using satellites and radar in particular, I understand. Can you tell us a bit more about that and maybe some of the transport resilience use cases that you've been using that for?
Sure. Okay. So satellite Earth observation provides some key benefits, really, and it's been used for several decades, as people know, to monitor global changes. So first of all, satellites are global in nature, so they can survey the whole Earth, and the data is collected consistently. So the data sets themselves are also openly available, so they can be examined by peers to ensure that we have consistent and collaborative science. So since they can scan very wide areas, they're often highly suited to monitoring large areas at a go, and they can provide data which can lead to data-led decision-making, really. So some of the things we've been doing to try and drive forward the best practice is Telespat UK, alongside its peers, are working in a project with the Construction Industry Research and Information Association, CIRIA, in an activity that's producing a guidance report on the application of Earth observation and interferometry to civil engineering infrastructure assets. So interferometry is a technique that utilizes radar satellites to measure ground movements. And indeed, this is being utilized, and Telespat UK is involved in the HS2 program utilizing this kind of data. So having this kind of data allows you to measure millimetric movements from space. And this has particular benefits, really, in that it allows maintenance and ground teams to be optimized, as the satellite data can be utilized to prioritize the groundworks. And this aids in minimizing the time that ground teams are in a dangerous situation, such as working on line side or on roadside, and also ensuring that inspection teams' journeys are optimized and that the journeys are indeed minimized. But it's important to highlight, as with all geospatial data, that to get best benefit is to use the data collaboratively and not in isolation. And to that end, Telespazio and UK and University of Edinburgh have been collaborating for many years, really, on the utilization of satellite-derived data and bringing those data into digital twins, really. And that's something, you know, Simon and ourselves have been working on a lot.
Fantastic. So maybe moving on to Simon then, from a University of Edinburgh perspective, just maybe to explore a little bit about that collaborative work that you've been doing with Telespazio.
Yeah, I mean, well, just to touch on something Geraint has just said, I mean, transport networks are a sticky problem when you're thinking about natural hazards, landslides and flooding, because they're long linear networks. So you can't do site inspections of the whole network. It's too expensive. So, you know, civil engineers have to plan when they're going to go out and inspect different parts, but the satellite information can really aid in targeting that activity. In terms of the collaboration, I think that is possible between private industry and universities. I mean, the increase in availability of satellite information has been really huge in the last few years. And processing that data lies in lots of different organizations. And I mean, I think previously, maybe 10 years ago, you need a bunch of supercomputers to deal with all the data. So I think academia has had some experience with trying to use those resources to make predictive models. So you need a lot of compute power. So that's something that we try to do, make predictive models of landsliding. It's very tricky. But communicating that to an actual manager of an infrastructure network is not really academia's forte. So I think that partnership can really aid in getting something that might use a lot of compute power that some academic is doing on a supercomputer, and then translating that into something that an infrastructure manager can actually use. So that's sort of what we've been trying to do over the last few years, and so have a lot of other partnerships that have been funded by various research agencies, European Space Agency, and others, which we might hear about some more in this session.
Fantastic. So that's a really nice example, I think, of different sectors of expertise coming together and using space data, real-time space data, but also feeding it into modeling, I guess, from predictive modeling and using it for transport resilience. If we can move on to Catherine from Airbus. So Catherine, you've been doing some interesting work using satellite data sets and AIS, automatic identification systems, in the maritime sector specifically. Can you tell us a little bit more about that?
Yes, absolutely. So fundamentally in the maritime sector, we want to track all activity of vessels. And I guess this is echoing some of the comments made by Hina earlier on. And currently at Airbus, we're using AIS and data from space for maritime situational awareness. That's helping us to track shipping behavior. So this can be useful to track illegal activities such as illegal fishing, which we know is more damaging to the environment in many ways, and also oil spill monitoring. And another critical aspect is the monitoring of maritime shipping emissions, which is really important for meeting emissions targets. And in terms of the greener future of transport, we know that sulfur oxides, for example, are key pollutants that come from the maritime sector. Variables such as engine type, fuel type, modes of operation, age of vessels, origin of vessels, etc., can have an impact on whether a vessel emits more or less sulfur emissions. And so one of our projects that we've currently got going on at the moment in Airbus is looking into modelling and mapping sulfur dioxide concentrations based on combining data sources ranging from satellite and ground-based data sets supported by artificial intelligence. And so the aim is to generate a constant map of sulfur dioxide on a daily basis and at a high spatial resolution, and kind of basically better than you can currently achieve from space-based measurements alone. And just briefly, another example is a previous project we've done where we've used satellite data sets in combination with AIS to monitor shipping emissions for the government of Canada. And this was over a marine protected area. So again, really important to understand how maritime emissions are impacting the area. And in terms of climate related regulations, with current clean air policies, and when new emissions policies are introduced, they need to be enforced and monitored to basically see how effective they are. For example, checking if adopting new fuel types makes a difference to emissions as mandated by the IMO 2020, for example, which puts limits on sulfur allowed in fuel oil. And as a space sector, I think we can support the measurement of the effectiveness of using a fusion of space and other measurements to monitor and model shipping emissions over time.
That's fantastic, Catherine. And just your middle example there about the modelling and mapping work on sulfur dioxide concentrations. So, I mean, can you give me an example of how specifically that's actually informed decision making and how it's shaping decision making?
Yeah, so I think this is currently something that we're working on. It's, to be honest, it's in early stages of development in terms of the technology. So we are really hoping that this will be used kind of on a global basis, and I think watch this space really.
Fantastic. Thank you very much. And then just finally moving on to Katie. So Katie, in McDonald's, you've got lots of experience, I think, of applying GIS and modelling in transport planning, which are definitely subjects, I guess, that I'm pretty familiar with. But can you tell us just a little bit about some of the geospatial work recently that you've been doing, some particularly innovative examples that you can think of?
Sure, yes. So yeah, in my role championing and leading on sustainability across transport, I'm particularly talking about roads today, but look after all the modes across the transport unit. The importance of data to give us a rich textual understanding about what the current situation is in order to predict forward for the future, so that we make sure that we build things that are the right thing to build to address the climate emergency in the right place, in the right time, that it's not going to be that you spend money now and it's just the wrong thing because 20 years from now people are traveling in different ways. That's really important. So we work across the project lifecycle. So an example, in the planning side of it, transport planning, like you say, which is the part of the industry I'm from, we might be using GIS data to understand where the gaps are in transport, where it might be that you, in order to get somewhere, where you, not as the crow flies, but the connections that you make through different transport networks, how you can get to work, for example, at different times of day, where the gaps are. And sometimes those gaps line up with areas of deprivation, for example. So we're looking at socioeconomic issues there as well, and social outcomes, and how we can connect people in and fill gaps, because the drive towards decarbonisation in the future is not just about dealing with climate change, but dealing with the world that we all want to live in. And when I say we all, that is we all. We don't want to be in a situation of people being left behind or disenfranchised. So we look at GIS-based data in that sense. We might also look at data in a planning sense, in terms of how you would want to deliver that electric vehicle infrastructure that we were talking about. We've got some really interesting conversations going on internally at the moment between our energy and our transport sectors. And that value of conversation and collaboration and communication is almost just as important as the data itself. There are some parts of the industry who've got great data, but if it's not shared, we can't learn from each other, we can't work together. And that's certainly a message I picked up from some of the earlier discussions we had. We would use it in mobility as a service. We're using it on the rail lines, for example, to look at where you can electrify and how you would fill the gaps where it's more difficult. But other parts of Mott MacDonald, to me, are also working across the different project parts of the project life cycle in the doing side of it. So thinking about design, construction, building. And in that sense, we have a digital platform called Moata. We have one that deals with geospatial data. We have a carbon portal where we can measure the amount of carbon that's being used, and in real time start thinking about how you can change carbon in a project to use different materials, to work in a different way, to think about innovation and collaboration and efficiency. We also might look at things like nature-based solutions. So we're doing some interesting work at the moment where we look at verges on rail lines or in road as well, and how you might bring in nature-based solutions to help in terms of the carbon perspective, but also in terms of resilience and make us good citizens in terms of how we deliver a project. We're not here to be engineers to make money. We're also here to be engineers to be good citizens of the world and to be better for the communities that we work for. And then also, if we're thinking life cycles, there's monitoring at the end of it as well. For all of that, data which is current, which is rich, which is wide, blending lots of different types of data together to understand the current situation and predict forward is really important, but also recognizing the uncertainty, because who knows what the world's going to bring. I think COVID was a good lesson of that.
Yeah, absolutely. And I think you touched on, I think, which is a subject close to my heart, how we can use geospatial data and analysis, particularly with social inclusion in mind, when we can map spatial transport services and link that to particular areas of deprivation where you have that mapped as well as access to jobs. That's certainly something we traditionally do in transport planning, but it is very valuable. So I think just in the very last bit of our session, because I'm very conscious we're rapidly running out of time, I just wanted to ask about some of the big opportunities and challenges you see ahead, the panel sees ahead in applying space and geospatial data to transport. And I guess, particularly thinking about COP26 and decarbonising, that mission to decarbonise transport. What do you see as the big opportunities there? If I could maybe start with Geraint and Simon, do you have any thoughts on that?
Yeah, I think one of the major opportunities we have is really to take advantage of the fact that these satellites are availability is growing exponentially, really, as new satellites go up. And the amount of data available through the application of machine learning and artificial intelligence to derive data sets on a national scale is there, really. So I think for me, one of the opportunities would be to scale up, really, would be to, rather than think of a project scale use of satellite data, is to think of it on a national scale. And there are activities starting in that direction.
Fantastic. And Simon, do you have anything from an academic perspective to add on what you see as the big opportunities, but also, I guess, linked to that, you know, some of the challenges, because obviously there's quite a lot of skill set building potentially, and making sure we have we take advantage of all the jobs growth in these sectors as well.
Yeah, I mean, decarbonizing the transport network is a big challenge. And I mean, I think that involves decarbonizing the modes of transport, but we also want to minimize the carbon budget of maintaining it. You don't want to rebuild things that are broken. Sure. And I think that, you know, we're not in a stationary climate, we're changing our climate. So the networks need to get more resilient. And I think the increase in satellite data can really aid in that. I'm just going to give a very brief example. So there's something called the European Ground Motion Service, which is about to come online. And that uses radar data to get this millimetric scale precision of how surfaces are changing. So you might be able to see if your road or rail is moving at very small scales through time. And I mean, if you were going to do that before that service, or now, before the service comes online, you would need to hire really highly skilled technicians, and that takes months, and that will become a service shortly. Yes,
which makes it all much more efficient and affordable by the public sector, I guess, as well, doesn't it?
Yeah, so that sort of thing, before you'd have to have a bunch of people with masters and PhDs processing data on their own computers and things. That becomes a service. So suddenly you've got an ability to base forecasts on that kind of data.
Fantastic.
It's totally game changing. So I think there's a lot of opportunities coming up to make our networks more resilient based on this
Excellent.
data.
And yes, making transport networks more resilient to climate change and adapting, that's definitely something that we're thinking about as well. Catherine, just briefly from you, some of the big challenges and opportunities you see ahead, and particularly linked to decarbonisation, some of that work you've mentioned already is already going in that direction.
Yeah, I think specifically if we think of some of the lessons learned that we've seen in the maritime sector, we've seen more and more different departments sharing data, and I think that's really crucial moving forwards for ensuring that, you know, different departments can actually work to address the problem. We've seen this firsthand in the UK maritime sector through, for example, work that we've done with the Joint Maritime Security Centre, where its data is shared across multiple maritime agencies. But I think this is also really important good practice to be replicated in other sectors across government. And I think perhaps just to follow on, it's worth keeping in mind that, you know, space can support decision making, but it can't solve all of our problems, even if we think sometimes it can. So I think we need to have, you know, more information on ground truth and validation data sets to ensure quality of measurements and modelling. And I think that's where industry can work together with academia to address this. So I think that will be really a few crucial points to address decarbonisation.
Fantastic. And I think there's maybe something around standardisation and standards, consistent standards of data in there as well, but also thinking from a public sector perspective, making sure that we somehow kind of translate that so people understand, you know, what questions to ask, how to use the data. There's a whole kind of skill thing there. And if I can very quickly finally just go to yourself, Katie, because we want to leave just a few minutes for some questions, I think. What would you say from your perspective are some of the big opportunities and challenges ahead?
Well, I put a tick against everything that everyone said already. That's definitely worth considering. In addition, I would think in the context of space and geospatial data that we're talking about today, that within the transport industry previously, and I'm sure it's the same in many industries, we would predict and provide. We would say, here's the way things are currently, we'll project forward to the future, therefore that's what we need. Increasingly, in addressing that challenge, we need to think about decide and providing. What future do we actually want and how can we get there? Not just that we project forward, otherwise we'll just end up with bigger and more roads. Also, I think it's important to center people in our technology, which is something I mentioned earlier. So we're not just thinking about technological solutions in the excitable way that we might do, but thinking about what the purpose of it is and how we use it in a way that benefits people, and not just people who can afford it, and not just people who are in the sort of the part of the industry that we might be. And then lastly, very quickly, I think that as we're looking at those challenges in the future, we need to think about the fact that we don't know what the future is. So there's a lot of uncertainty there, and how do we act for that, particularly considering behaviour change as well. It's really important to remember that transport is an outcome, not an output. So how do we get people to where they want to go and give them the connections they need? And some of that might be through digital and through placemaking, as much as it might be also from transport connectivity. So it's that triple access system of getting people what they need in the future, so that we can all live in a way that helps us to decarbonise the industry and the planet.
Yeah, fantastic. And it kind of speaks to one of the problems I'm grappling with at the moment, where I mentioned the innovative location services data set that we've been working with University of Glasgow. It tells us where people are going currently, but it doesn't tell us anything about where people might want to go, but currently can't go because the transport systems don't serve them. So if space and geospatial data could come up with a solution to that, that would be fabulous. I think I'm just now going to hand over to see if we've got any questions from our questioners.
That's great. Thank you, everyone. That was a fantastic panel, and there's some real kind of key messages coming out around collaboration, sharing data, combining data, also around the kind of need for resilience within the networks. But Katie, you touched upon the kind of people side of it, and that actually ties into one of the questions that we've had from the delegates today, from Andrew from AstroSat, and that's around that kind of citizen side of things. So how do we tackle transport poverty? And how can that lead to carbon production? They have also worked on a Get Glasgow Moving map, but it would be interesting to hear the panel's perspective of that. How do we address transport poverty? We have all this, as we said, we've got all the availability of the technology and the satellites, but what about people and the citizens?
That's a really good question, and we could probably spend the next hour of this session talking about that as well. So I'll try and be brief. I think part of the answer is variety and choice. So we're not, for example, considering that electric vehicles are the answer, whether that's a car or any other form, but also thinking about the different modes that need to be out there, that people don't always have to travel, that we need to make sure that we provide connectivity that works for everyone. And currently an electric vehicle is something that works for people who can afford it, and you need to be earning quite a bit to be able to afford it. So being sure that we think through all of that, and part of that also then starts to think about financing. So how do we finance our transport so that we have a system we've all seen through COVID in the UK in particular, but I'm sure it's something across the world, that how we get public transport to work and operate in a way which is user-friendly, which people want to use, goes where they want to go, is affordable, and is also something that you can finance as an operator as well, is a key question. I think it's a difficult one to answer in a short space of time, but I think the answer is, just as you were saying earlier, bringing those different parts of an industry together, working together with social scientists as much as we would work with data and geospatial and spatial scientists to think about how we can do things. And one of the messages that have come out earlier as well is that data and digital and space can give us efficiency and reduce the cost in developing things. So hopefully we'll be in a position as time goes on that we can get a public transport system that works for everybody, as well as bringing in things like mobility as a service, which was also talked about earlier.
Great, thank you. And another question which kind of ties in again to the kind of the people side of things is, how can data be created and transposed effectively to be used by the disability community, whether that was sight impairment or hearing impairment, or what can we offer in terms of access to new forms of digital information? Deborah, that might be one for yourself in terms of the kind of council's approach to things.
Well, it is a topic that I personally and professionally been quite interested in for a while. So I think probably everybody's aware of, I'm really keen on the kind of citizen engagement aspect of something like OpenStreetMap, where it's kind of like crowd sourced come together. And I've often thought how it has an open cycling accessibility, open cycling layer in there, but it would be great if we could create almost like an open accessibility layer version of that. And that, I think geospatial data is really important for that, because it would almost pull together a number of different layers of geospatial information based on accessibility. So, you know, where dropped curbs are, gradients, the sort of mapping of which retail stores, etc., cafes have accessible entrances, where disabled toilets are, all of these things, maybe where information points are for people with. So, you know, geospatial is really relevant to that. And I think there's a big project there, which I mention whenever I can, in the hope that somebody somewhere will take me up on it and start to create that kind of layer. But then that would feed into lots of innovation out there. There's already innovative routing apps that you can get that ties directly into OSM. So I think there's a real opportunity there to benefit the end user. It's an excellent example, I think, of how we could use geospatial data for good.
Wonderful. Thank you so much for that. Thank you so much to the whole panel for sharing your expertise and your experience and talking about what you've done so far, and carry on the great work and carry on shouting about all the amazing stuff that we're doing here in the UK. So thank you so much, everyone. We are now moving on to our next wonderful panel, which will be hosted by Ken Gordon, who is the European Space Agency ambassador here in the UK and Scotland particularly. And we will hand over to the lovely Ken to introduce his panel of experts and to speak about what the future of transport is going to look like.
What a lovely introduction, and thanks very much, KTN, for having me here. Why is European Space Agency here? Well, we fund lots of projects that involve space data, anything to do with space and the integration of space. And if there's something that's come out of panel one, it is all about interoperability and connection and the human factors. As a child of the, let's just say, 60s, I always had this sci-fi thing about sitting in a queue of cars, and it does happen on a daily basis, pushing a button and rising above everyone else to drift to my destination. Little did I realize that never mind whether that was possible, but the technology, the jets or whatever, the rockets to do it, would be environmentally dreadful. What a slap in the face this has been. It's a delight to chair this panel on the future of transport, because it's something I'm really passionate about. And I'm very lucky to have Alejandro Gutierrez and Michelle Carter on the panel. I would ask you to introduce yourselves if that's at all possible. Alejandro, would you like to start, please?
Yes, hello. Okay, so I'm a postdoctoral researcher at the University of Edinburgh, and I work in mathematical optimization, and my role involves close collaboration with the construction industry, looking at ways of reducing their carbon emissions and by making better decisions. And my current research is in the context of an UK-wide plan to electrify some of the major roads in the country.
Electrified roads, there's a thought.
Yes.
Michelle, please introduce yourself.
Thank you, Ken. So Michelle Carter, I'm Head of Transport at KTN. So we connect people and connect innovators to accelerate growth, and some of the projects that we've been working on in KTN, our transport team, for about supporting UKRI in the Future Flight programme, for example, and big programs working with government departments around electric vehicles, the Clean Maritime Demonstration Fund, and we've also got an innovation exchange program. So we've been working quite a lot with various councils and organisations, and particularly more recently around decarbonising fleets and supporting them and helping them find the right technologies to that. They're just some of the things that we've been working on.
You've been involved in a lot of different things. Oh, hello, Tim. Welcome. Welcome from a vehicle, I'm guessing, which is kind of appropriate for the future of transport.
Good afternoon, and apologies. So I am at Physical COP. It's Tim Emberley. I look after research, innovation, emerging technology across the Costain Group. I also have a very active interest in carbon, and I champion carbon across the infrastructure industry as part of I3P, which is a client-led initiative to drive innovation into the infrastructure sector, and also kindly hosted by the KTN, who provide the facilitation and secretariat role.
Thank you, Tim, and welcome. Maybe we should all have arrived in some sort of vehicle. That would have been cool. Each of you, I'll ask you this, a very general question to start with. Alejandro, what to you does the future of transport look like?
The future of transport. Okay, well, I guess that the future of in the long term, nobody actually knows how it's going to be like, right? And the only thing certain is that it has to be sustainable, because currently it's not very sustainable. But the only way forward is to adapt to the limits of our planet and natural resources. That being said, it seems that transport, this has been said before today, is that it looks like it's going to be more and more data-driven. So optimization and AI can help transport to be more efficient. This meaning being faster when you're traveling, or to require less energy when you're traveling. And well, we also need to be aware that AI and technology, innovation, anything in general, can only help to a certain extent, but they can do something. But there's also, in some situations, they can even help more. So if you think of autonomous vehicles, for instance, okay, they make our roads safer, for sure. But the presence of this technology on the roads, this is not research that I'm doing, but it was something that we were contemplating also. It also means that they can be connected and they can collaborate together. And this means perhaps that, for instance, they can follow strategies that can dramatically reduce the consumption that they make. If you imagine, for instance, heavy goods vehicles traveling in platoons and consuming much less energy together.
Okay, thank you, Alejandro. Michelle, the same question to you. What does the future of transport look like to you right now?
So within our team, we've come up with 4 strategic priority areas that we're going to sort of focus on, if you like. So the first one is connected transport. The other is automation, decarbonisation, but also accessible and inclusive transport. And then with each of those 4 pillars, there are various aspects that obviously need to come to the forefront to enable that to happen. So these connected transport, that's going to be heavily data driven. So I agree with Alejandro on that point. You only need data. It needs to be open access data as well. And that's going to enable innovations to happen, but also improve efficiencies in the way we move people and goods. And the automation aspect, that's going to be increasingly important as we move forward to enable those efficiencies to happen. And of course, decarbonisation is absolutely key across all the modes as well, but also critically is enabling more active transport as well, so that people have a choice and we have more low carbon, zero emission options, and ensuring that transport is accessible to everybody. And that sort of helps grow the economy as well, as more people have access to healthcare, jobs and education. Those are going to be the key things. And I just wanted to highlight one thing that I came across was this vision in the US. I don't know if anybody's come across this on Tolosa, whereas if they're going to build a brand new city, and if it raises an interesting question, if you're going to start completely from scratch, what will the transport system look like? It's going to encompass everything from healthcare to jobs and education. But if you're going to plan the transport system right from scratch, what will it look like? And the imagery is quite cool. You've got flying taxis and
yes,
autonomous pods and people walking and on micromobility as well. Good vision to have.
Thank you. I feel justified in my opening up there. That's great. Tim, how does the future of transport look like to you right now?
I think it's a tremendously exciting future. So the reason why I say that is because as an end user, as a citizen, I think we're going to have so much choice in terms of transport systems. And it's really exciting in terms of where we could be in terms of the interoperability, what we could be doing whilst we're being transported. An important part of this debate is not just the human side of things, moving people around the country. It is also around our goods. And if we think about how our buying behaviour has changed, the expectation in terms of delivery, the here and now scenario, the Amazon ordered today, get tomorrow. We're going to see massive change in terms of the delivery of our goods and services. So I think in terms of those 2 parallel tracks and where we are, it's going to certainly deliver some big challenges for us to think about. but also in terms of the carbon debate, in terms of how we go about doing it. And this is going to be some really interesting challenges, but also start to bring different industries together. I work in infrastructure, and in the past, we never had to talk to the transport guys, or we never had to talk to energy. But I think now we're going to see different disciplines coming together, integrated teams, collaboration, and just trying to actually find the solutions that are actually going to sustain our world. So for me, it is all about the diversity of modes, the needs of the end users, whether that's people or goods and services. But importantly, we really must accelerate our carbon journey and understand it from a scientific point of view. Alejandro is absolutely right. We really must start to use data wisely to make the right choices.
Thank you, Tim. A follow-up question on that, Tim. You've talked about multiple modes. Are we going to come towards some sort of again, something mentioned in the panel one, a standards battle?
Very much so. So I've just come out of a debate at Scania's office. We had 150 people at Scania's office. And in terms of the technology solutions that they're bringing into their heavy goods fleet, it's one of the biggest parts of the sector to decarbonise. We all want decarbonisation. Government have announced in terms of the phase out of diesel fuel. And the industry is actually calling for standardisation. One thing that we have learned from the from the Evie over the last few years with cars is that the biggest challenge for the end user is just getting the right plug for the right socket. So as we go into the future, standards are really important to make sure that we've got consistency. Importantly for industry, clarity. We need clarity in this. If we're going to make some significant investments and we want to see this change, we need a joined up approach. We cannot do this alone. And therefore, a joined up approach around standards will allow industry to have confidence and will invest in innovation to transform. And we're all looking to transform our businesses because we have made those commitments to carbon.
Goodness me, all of us have experienced that whole connector thing in various ways. That's a very good point, Tim. Alejandro, in terms of practical implementation of e-highways or electric roads, roughly, if you could summarize very quickly, where are we? What's happening?
Well, at the moment, there's a plan for electrifying the country. There's going to be a section of a road that is going to be tested in the country, like other countries have done, like Germany and Sweden, I believe. And this is the current state. But the idea is to electrify the whole country, and this is where I come in with my research. So we are working on different questions that regarding the questions and the challenges that different stakeholders have on this project, helping them to make better decisions that can be translated into emitting less. Okay, so for example, one of the things that we've done at the moment that we have already addressed is imagine that we have the realized electric road network. What are the best routes that the vehicles should take, meaning that they would produce less carbon emissions, or similarly cheaper because they can be done mostly on electricity, and of course considering the deliveries that they have to make. And we've taken it a step further and also consider what happens when when the vehicles can decide how much payload they can deliver to each customer in the network, depending on their demand. Okay, and even more, what happens when the demand of these goods is uncertain in these locations, when all we know is the probability that the demand is this or that, depending on the time.
Yes.
And another of the important things that we want to address following this is on the, okay, we have a budget for electrifying the roads in the country. So what's the best way to do that, right? And by this, I mean the one that would minimize the global carbon emissions of all of the vehicles that are using the network. Yeah, so that's a very interesting question that we're
That's a very good point. Michelle, I know you have a special interest in the role of emerging aviation solutions, just to move away from vehicles and HGVs. How do you see the role of emerging aviation solutions in creating improved freight and passenger services in the future?
So the government has invested of course, in the Future Flight Challenge programme, and by 2030, the ambition is to have created a fully integrated sort of almost mobility as a service style of operation and to enable goods and services to move more seamlessly and people to move seamlessly, but also sustainably, and to enable a more rapid transport system for all. And we know at the moment, so in terms of that evolution trajectory, we've got drones operating at the moment that are delivering. We've seen that during COVID. They were quite useful in terms of delivering PPE and negating the social distancing barriers during COVID. So the vision is eventually we'll have this fully integrated aviation system, but not just various types of aircraft flying, but also connecting and creating these multi-transport hubs, so that it can, the idea being that it can connect, a passenger can connect easily from the flight to perhaps a train service, for example, or other form of public transport. So to enable these new aircraft solutions to fly, it's going to require the digital and physical infrastructure. So things like vertiports and the ability for people to book on demand, for example. And a great sort of example of a project that's happening at the moment there's 48 projects that have been funded through the Future Flight project programme at the moment. Is Coventry Council are involved in a project where they'll be setting up the world's first vertiport. But the great thing about these vertiport systems is it's quite flexible. It's like an IKEA kit. You can build it up and then take it back down again. And I think that's an interesting concept in terms of enabling that flexibility for planning purposes within cities and regions, for example. So it kind of future-proof their sort of flexible transport planning and so that it can flex with the needs of the residents.
Sure, and coming back to the point about building stuff that is going to be sustainable for decades and decades and decades to come, so you can change your position of things as needs change. We're short of time. I'm going to ask each of you one question, and that question is, what's the next thing that needs to happen to move us forward on developing solutions to the future of transport and sustainable transport and decarbonisation? And if I could start with you, Tim, because you're there on my screen, what's the next thing that needs to happen? Oh, you're on mute, Tim. Sorry.
No, it's okay. I was hoping for a little bit more time just to think about that question.
Okay.
But
I sprung it on you.
No. I think greater clarity as an industry, and I think this is where the Venn diagram needs to come together. And certainly, I'm a great believer in academics working very closely with industry around policy needs that the nation has decided on that's really important. So for me, it's greater integration, greater collaboration of those people really in the epicenter of change. And we really must work together as a nation to put roadmaps in place to address some of these big challenges. No single business, no single group can do it alone. So for me, it's about collaboration, integration, and a clear way forward.
Thank you, Tim. That was very concise for being so spontaneous. Alejandro, what is your view? What's the next thing that needs to happen for us to have a decarbonising agenda, the future of transport?
Well, it could be many things, but from my perspective as a researcher and with what I'm doing, it would be around having access to more and more data. So for instance, for this project, we're using data from traffic monitoring units. and other sensors that give you historical data of traffic volume on many sides of different roads, and this can be used to take decisions about where would be the best location for installing these electric roads. But GPS data, for instance, containing the tracks and the routes that the vehicles follow, which could include the locations also where they, with these vehicles, stop for refueling and resting, if they have the time stuff with the locations, could be very useful for taking decisions on the design of the electric network.
And Michelle, you've got the most time to think about it. What's the next thing that needs to happen?
Yeah, but it also means people pinch my answer. So I was going to
sorry.
say I would totally agree with both of those, but I was going to actually say collaboration is absolutely key. I mean, that is essentially the core of what we do at KTN anyway. But so you know, we see the impact of that all the time, and they, you know, making those key connections and that people collaborate, and then magic happens and great things happen. Sure. So it is definitely, and that ability to bring the disparate communities together and innovators that don't normally work together is going to be absolutely key. And yeah.
Thank you very much. And now, can I throw to the team sitting there in the nice shiny office? Do we have any questions?
Yes, we do.
Good.
I had a question actually, and it relates to the discussion that the panel has had. And the question is, how do we ensure we don't lock ourselves in for just one solution? How do we ensure that we allow ourselves to be flexible as things change? Like you said, the future is unpredictable, and the best way to get it, I guess, is to create it. But how do we make sure that we don't create a transport network, kind of what Simon was saying earlier, that just makes that we're trapped in it? And that was from Andrew from AstroAgency's.
Okay.
Who would like to go first? Yes, Alejandro, yes.
Okay, and maybe I can start with that. Okay,
sure.
So one of the things would be using the current infrastructure that exists. And with this, I mean, I mentioned things about platooning vehicles and electric trucks. So when you put them both together, you have trains, right? So you have a network, a railway network that could be used for transporting goods as well, and that it should be maximized in use. Of course, we need also trucks, but that's something that it should be used as well. For instance, for example.
Michelle?
Yeah, I agree. I think you know, we don't have the beauty of being able to have a blank canvas to start from scratch. So we do need to, we're going to kind of have to retrofit with what we have and work with what we have. And being able to create, I guess, more flexibility in the infrastructure, and I guess within that, yeah, we can create more flexibility within that infrastructure that we currently have to enable more options to be available.
Okay, thank you, Michelle. Tim, you should know that a portal has opened beside you in your car, just saying. There's maybe another dimensional thing happening there. Tim, how would you answer that question?
Yeah, so I think for me, it's really important that government provides a clear framework to allow the private sector to innovate and to really come forward with solutions that are flexible, that meets the needs of society. So for me, it is very much around policymakers working very closely with industry to set the framework to allow the private sector to invest with clarity and certainty, to develop innovation that we all want. We want that flexibility, but also going back to my Venn diagram, the researchers, that there's many unanswered questions that we need support, and we need clarity research done. So for me, that research angle really needs to start to address some of these big challenges we've got in and around future transport.
Thank you very much, Tim. Do you have any other questions? Team in the office.
No, Ken, I think you've stunned everyone into silence. So that was
Ooh, that hurt. Thank you very much, Christina. Do you want me to say anything else, or shall I hand back to you?
No, we'll get you to close the panel, and then we'll say our final remarks.
Okay, panel, thank you very much for taking part in this. I think what I like about this and all the proceeding speakers so far is we've raised questions, we've raised points that people didn't, I'm sure, attendees haven't thought about, haven't considered, and are provocative. And let's face it, a lot of the provocation, a lot of the issues are going to be around how we as humans, never mind the tech, how we as humans actually deal with the changes that are required in our lifestyle to achieve this decarbonisation agenda and to achieve a sustainable future. So thank you all for being with us today. I'm assuming there will be lots of contact and questions and follow up with this. And I think, as with any of these events in this series, this is a beginning of a conversation, I think. So thank you all, panel, for being here. Thank you, KTN and team in the office, for having this panel and inviting me along. I'll throw back to you.
Thanks very much, Ken. So that brings us to the end of the Future of Transport session, which will be available for 90 days on the platform. So please do share it around, share it with friends, connections, family members, anybody you can possibly think of. Now we're going to head over to the virtual pavilion for some networking, and I hope you'll all join us there. But just before we do, just to reiterate Ken's points, massive thanks to everybody. Big thanks to KTN, to the panelists and to the speakers for what's been a really engaging discussion today, very interesting. And most of all to the audience for joining us today. So yeah, we'll see you over at the networking, and thanks again.